So here we are, simplifying safety and streamlining commercial solar with the focus on UL 3741 and the partnership between K2 Systems and SMA. And you're seeing here on this cover page here, this is our new south face system about to launch. So here's our agenda. We're going to be going through how we got here. So some of the objectives and background of both the NEC 690 code and the UL 3741 standard. We'll be going through some of the requirements for the testing background as well, and what SMA and K2 has had to go through with listing our systems together, and then the solutions, some of the south face features and SMA features, wire management instructions, assembly instructions to comply with the 3741 standard, and then end with some of the benefits of why you would go with a 3741 compliant installation. Do a little brief history too. So if you don't know K2 Systems, I'll give you a quick intro. So it's born as a German company in 2004. And in 2012, opened up the United States office in Oceanside, California. And then 2015, Mexico opens, and under the name of Everest. So if you might have heard of Everest Solar Systems, that's how we had to open up shop due to some licensing and naming rights. But now we are all finally under the K2 Systems global umbrella. So K2, like I said, is a global company here with offices all over the world. So at K2, we have our regional product specialist that can walk you through right from the beginning of a project to the installation. So if you have any questions about that, we'll give some contact information at the end here. But yeah, reach out, to your regional project specialist in your area, and you can also find that information on our website as well. But yeah, we can walk you through project planning, design, installation training, all that, and I'll hand it over to Mike.
Awesome, thanks. SMA is also a global company. SMA America is the largest subsidiary of SMA globally. We will celebrate our 25th anniversary in September, so excited about that. The install base and some of the history of SMA you can see on this slide, but have quite a bit of history in PV inverters. That is where we really started, make some storage inverters now, but many years of making PV inverters and working with advancing technology in safety codes like the UL 3741. Also, there is a great amount of not just technical training that I would represent from the Solar Academy. There's an applications engineering team that would be happy to help with any technical questions related to 3741 or design as well.
Great, thank you, Mike. All right, so let's get into it. These first couple slides, I'll be reading a lot. It's a lot of text heavy, but as we go through, that'll get a little easier on your eyes. So sorry for the first couple slides here, but just I find it interesting on how we got here. So I wanted to give a brief overview of the NEC 690. If you aren't aware, 690.12 is our quote unquote rapid shutdown article in the NEC, the National Electric Code. But the objective is to keep firefighters safe when performing emergency operations, in the vicinity of PV array equipment. This is an image up there from the Department of Energy of some firefighters getting some training on a ground-mounted system. And then there's the NFPA, National Electric Code 2023 as well on the right. So a little bit of the history. In 2014 code cycle, the 2014 NEC introduced rapid shutdown of PV systems on buildings. So what that did is controlled conductors leaving the array boundary, was defined as 10 foot, and we were limiting the conductors to 30 volts at that point. And that kind of stayed the same throughout the all the way up to 2023 code cycle. In 2017, at least for the voltage, the 1 foot, the 10-foot boundary in 2017 was now defined as 1 foot around the array boundary, and now we have some limitations on inside of the array, the controlling the conductors inside of the array, not just leaving the array boundary. So outside remained to 30 volts within 30 seconds. And then we had a couple different options to comply with inside of the array boundary. One of those being limiting the conductors to 80 volts within 30 seconds, or this is where we first came to know the concept of having some kind of PV hazard control. Like I said, the concept was just at the beginning stages. We didn't have any standard to go by. That'll come later in the 2020. But we had the other option to list and label or field label the PV array as a rapid shutdown PV array. But there wasn't really any option to do that. It was just kind of planting the seed there because we didn't have any standard to go by. Now in 2020, the introduction of the UL 3741 standard. So STP, Standards Technical Panel, was formed, and through UL came up with the PV hazard control system. So in 2020, we had this, like I said, the same outside limit of 30 volts within 30 seconds, but now inside the array boundary, we have that second option. So still remaining that limiting the conductors to 80 volts within 30 seconds, or now we can install a PV hazard control system. In 2023, there was just further clarification on that second option, and have all of these new acronyms in the solar industry. So we have, PV hazard control systems, PV rapid shutdown equipment, PV hazard control equipment, as listed means to methods to comply with that NEC 690 article of controlling the conductors inside of the array. And I always find this interesting. So this was in effect as of February 1st, just a map of what states are adopting this new or which version of the NEC code states are adopting. So in 2023, we do have 17 states already adopting it, now 2 years in 2025. Still 21 states on the 2020 code. So that's more than half or a majority of the states that statewide are adopting at least the 2020 code that has these PV hazard control systems listed in there. 2017, we have 6, and 2008, we have still 2 states there. And I mean, ultimately, it comes down to the county, even though some of these might be adopted, or some of these statewide adoptions might be on the 2017 or 2020, it still ultimately is up to the authority having jurisdiction in your area. And actually, you can see 4 states here: Arizona, Missouri, Illinois, Mississippi, that don't have statewide adoption. It's down to the county level.
Yeah, like you say, that makes it a total hodgepodge of codes. But as you showed, that's like 44 states plus probably the big cities and 4 others are on 2017 or higher, where this is all applicable, 3741. Yes.
And then, so that is the code, a little bit of the background and objectives of what that's trying to do. It's all about, it was listed as first responders safety protocols, but now it's, really we're talking about firefighter protocol. So, and firefighter safety, keeping the array, safe. And I mean, a PV array, we can preface it as, PV arrays in their normal state, if installed by qualified personnel, are safe to touch, right? That's what the code does. That's what the NEC code, if they're installed to the NEC code, then they are safe. But what we're talking about is if there was any kind of damage, whether inflicted by a firefighter or other means, how can we keep those arrays safe if they are, maybe they light on fire, maybe there's some kind of damage to them. And so that's what 3741 sought out to address. So the scope is to, for firefighters performing operations on buildings with PV arrays could be exposed to electrical shock hazard from damaged, in italics there, PV equipment, right? So this set out some requirements to provide a means for evaluation of PV equipment, components, and systems that reduce the level of shock hazard after that rapid shutdown initiation function. So here's some of the history now. What we didn't have quote unquote rapid shutdown or controlled conductors up until 2014 code cycle of NEC, right? So there was a legitimate concern from firefighting communities, fire departments that didn't have a clear understanding of the hazards of PV systems, and how those could pose a threat to them. So enter 690.12. So we needed to get something into the code to address this and give some knowledge and understanding to these firefighters who, for fair play, they didn't. There might be cases where, if there's solar and they don't know how to shut it down or didn't have the understanding of how those systems works, might not want to, or not fight these fires as aggressively as they would if there hadn't been a PV array. So that needed to be addressed, and that was the impetus to get something into the code. We already had these off-the-shelf options to address module level control. So the code kind of revolved around those options under the assumption of 80 volts being safe, without real testing and data behind it. And then the next step to that was the STP with UL was formed and included industry experts, fire service members, and we determined how dangerous current could pass through a firefighter, what the probabilities were, what those shock level hazards were, and a means to evaluate that. Did you want to add anything, Mike?
Yeah, no, I reemphasize exactly what you're pointing out, that the benefit of having 3741 is there is actual testing done on these systems in damaged conditions when they may be wet, firefighting foam around them, to ensure safety. Because I do think, fire crews probably do not understand the ins and the outs of 690.12. And so when they come to a building with, a PV system on it, if it's built to 3741 versus relying on, devices, or maybe not have devices, if there is testing for these systems for firefighter safety, that is the best way going forward. So I do think that rapid shutdown code will never go away, but the reliance more on this 3741 standard versus that, 80 volt data sheet not tested under conditions of fire, is far safer for firefighters. And so again, that is the whole purpose of rapid shutdown. So it's good to see it going this direction.
Right, and like you said, now we have some testing to back it up. This is a good thing for our industry. We want to avoid and it is probably safe to assume that 80 volts is more safe than 600 volts, but still we were working on assumptions, and so this is good steps forward. 3741 for our industry, getting more testing and data behind these evaluations.
Yeah.
Okay, so that was a little bit of background. Let's get into some of the 3741 listing requirements. So I'll start off with 3 key features here that we need to keep in mind when designing or installing these types of systems, or looking to just researching into this and seeing if it makes sense to install one of these systems. One of the first thing you have to do is the modules, inverters, and racking all need to be certified to their specific standards. That being over here on the left side here of the screen, you have this is taking a holistic system compliance view, right? So the UL 61730 is your UL standard for module safety. 1741 for inverters, 2703 bonding, mechanical, fire classifications for racking, and all of those. So all of the components within the system have to be certified and listed to their specific standard, but then also we need to have those modules, inverters, and racking all listed together under 3741. The next thing would be, design the array layout under one of the approved use cases. And all of those use cases take into account the array boundary. So we have the definition here of an array is a mechanically and electrically integrated grouping of modules with support structure. So that's key, with support structure, including any attached system components such as inverters or DC to DC converters and attached associated wiring. So what that means is the array is everything, including racking, modules, wiring. So when we're talking about an array boundary, now we're taking the array into account, which is all of those components. So we have a 1 foot boundary for that number 2 there to design the array layout under one of those approved use cases. The array boundary for those use cases, and we'll get into those in the next few slides, is a 1 foot boundary around everything, not just the modules themselves. And then the third key is to follow wire management instructions to secure the wires away from potential firefighter interactions. And those are the 3 main things that we're looking at. And one of the ways to do that is to be using a UL 1565 or UL 62275 wiring device. So either a positioning device or cable ties that will secure those wires away from those interactions.
Yeah, one thing on this that I think is really important to emphasize for folks who are not living and breathing 3741 like some of us maybe, that 3741 is dealing only with the inside of the array requirements for rapid shutdown. Those outside of the array requirements are not covered and are not changed. Those conductors have to go under 30 volts within 30 seconds. There is no other method for compliance. And so you may see over by the little white box for the inverter, the PV rapid shutdown equipment listing for the inverters will cover that, the AC conductors leaving the inverter. So most of the effort for 3741 is focused on the nuance of inside the array, which is much more complicated, but it's just the inside of the array requirements.
Thank you for that. All right, now let's get into some of the testing that we go through, SMA and K2, to provide you guys with a 3741 listed system. So some of the preface to, like I said, with 3741 is the associated PV rapid shutdown equipment and PV hazard control components need to be listed to their specific standards. So with racking, we have to list a UL 2703. That's mechanical load testing, fire classification, and bonding. So you can see here we have some fire tests being done, and we throw flames basically at the racking, the tire assembly, racking, modules, and clamps to get either a class A, B, or C fire classification, depending on if the racking itself attributes to any of that, the fire moving across the rooftop. And then at the top there, that's some of our bonding testing being done with the clamps and one of our legs of our south face system. And mechanical load testing as well. So basically just putting weights onto the array or onto the module as it's attached to the racking under a certain time limit to test if it moves or comes loose from the racking. So, we do positive, negative, and lateral. And there is none other than my good friend Nick Pack there, Director of Product Strategy for K2 Systems, helping with that lateral test. So we have to do a lot to set these up. We have to come up with a jig to actually get these tests done, and then connect all the testing, the racking, and modules for the actual test. And then we also have UL 1565 positioning devices, something that we're going through right now, actually, with one of our new products, the K2 Dragon Clip, which is a 4-wire clip, and we'll get into that a little bit later.
Yeah, the inverter testing is way less fun. There's no destructive testing. We don't get to set things on fire. Very boring. But as we mentioned, the inverter has to deal with any control conductors outside of the array, so the AC side of the inverter. So there is the PV rapid shutdown equipment listing for the SMA inverters that we're talking about, and that documentation, if needed, can be found either on the UL website or SMA's website as well.
Awesome. Yeah, so I won't dive too deep into this. These are just snippets from the standard itself, UL 3741. And I think UL has a viewer that you might be able to download and just view for free. Maybe not download it, but at least view it. But these are some snippets. I'm not gonna, like I said, dive into it, but just to give you an idea of what we're talking about. So this is the safety analysis involved with UL 3741. And what happens is, here's the flow chart up at the top right. We identify the equipment that's going to be used in the system, and then go through a safety analysis. And what that involves is, specific shock hazard levels, 0, 1, 2, 3, up to 40 milliamps for a hazard level of 1. And I think if you go past that 40 milliamps, then you can see in the flow chart, adequate hazard control demonstrated. If no, then validation testing is required. And I'll go through some of that testing in the next slide. But the standard takes into account possible fighter-fighter interactions and their probabilities. So stepping or walking on an array, crawling onto an array, falling onto an array with a knee, foot, falling onto an array with a tool, a simulated fire axe, and then the probabilities of those happening associated with the shock hazard level.
Yeah, while this is a lot of complicated information, it's nice to see that the current there is the important thing for firefighter safety, not voltage. And so that is how you can get compliance and safety, even if there is not voltage reduction. So it's important to understand that the 3741 successful listing may or may not include voltage reduction within the array once rapid shutdown is initiated. It's all based on this testing that you see in this flowchart.
Correct. Thank you. And so here is some of that testing. So to simulate some of those firefighter interactions, we have a simulated axe drop, a firefighter fall, and foot pressure. So we have a chisel tool that's dropped down onto the modules, which are attached to the support structure, the south face system, and simulate that test. Same thing with the other two. Simulate those tests. Drop a 125 kilograms. So what is that? I think it's around a 300-pound heavy bag, basically, that they're dropping onto the modules attached to the racking, and then they do a test where they measure the current leakage and see what those current, like you mentioned, Mike. It's about current that we're trying to define and how it could pass through a firefighter. All right, so here's a couple of those use cases that I alluded to earlier here. So we went through some of the testing, and now how do we actually apply this? What are the installation methods? And each manufacturer, we have our own installation manuals, installation addendums associated with the systems that we have listed to UL 3741. You can find those on our website, and they'll go through all of the listed components that are approved for use, but also how to actually install those, the use cases, and some of the wire management techniques. So here we have case 2 here down at the bottom. It could be case 1 and case 2, but you have the array boundary set at 1 foot. And let's assume that there's a sub-array sitting here at less than 2 feet. So 2 feet from the edge of the array, which we've defined as racking or modules or wiring, all together. So there's a 1 foot boundary around the entire array. If there's a break, like at this subarray here, there would be a 1 foot boundary set around this subarray, 1 foot boundary set around this array. So now we're talking about 2 feet between these two arrays, right? Because those would overlap. So if we go beyond that 2 feet, like in this case here on the right, I guess let's start with if we were still less than or equal to that 2 feet, we have the inverter set at 1 foot within that 1 foot boundary, which is going to control the conductors leaving the array. We are allowed to stay within at that 1000 volt limit within the array. And same thing over here on the right, we're allowed to stay within that 1000 volt limit within the array. But that is if the array is connected to that inverter within the 1 foot boundary. So if we now break up that subarray going past that 2 foot, we have a few different options we can use here. Some kind of isolation device between these arrays, because now if the conductors go outside of that 1 foot boundary, they're no longer considered within the array boundary. So now we have to control those conductors that are jumping these two subarrays. And Mike, do you have something you wanted to add here about maybe the tri-power?
Yeah, I think this is definitely a common question that the apps team from SMA fields, a situation exactly like you have for case 3. If there is a break, the array is so large that a thermal break is required, or it's just a walkway or some other conduit run for equipment on a roof. And there's a cause for a break where code would consider these, as you said, 2 subarrays. What should folks do? And generally, there is discussion of string isolation devices, but I think a lot of what SMA would advocate for our situation for large commercial is that generally inspectors who don't understand this, they would be more comfortable seeing, controlling inverter by subarray, controlling inverter by subarray, the core one and the STPX, which you have the image of here, scale from 20 kW up to 62 kW. So we have a range of inverters that will handle, the same stringing. It may cost a little more dollar per watt, but both for installation without screw ups, where do those string isolation devices go? Having an inverter dedicated to each subarray generally makes the approval and installation of a 3741 system much more straightforward. So that would probably be our first recommendation. Does it make sense to have, maybe it's more inverters than you thought of, or could, maximize and design, but it makes everything go more smoothly. So a lot of times we'll find people mixing and matching the core one and STPX on a single rooftop to do that, because you might have 1 or 2 more inverters on the site, but it removes the need for consideration of MLPE devices or string isolation devices. Moving towards residential, I think there's probably much more thought and activity going towards these string isolation devices, because it's a lot harder generally to put a residential inverter near the array. And that's kind of a different topic, but we're actively looking at for our residential inverters. But I think for commercial, we would advocate having folks look at the full range of inverter products from SMA and seeing if allocating an inverter to each subarray makes sense, because quite often that's the easiest to understand for everyone involved solution. So right, generally we'd go that way.
Easier to understand, easier to install in some cases, right? So you have maybe you have a core one up for the larger array, and if you have some kind of obstacle on the roof, you can't get those subarrays close enough, you can go to maybe the Tri-Power X, which is a little bit smaller to handle some of that smaller array. Like you said, you have that kilowatt range, 20 to what was it, 60 for the Tri-Power X?
20 to 30 for the Tri-Power X, and then 33 up to 62 for the Core 1. And so they play very well on similar systems. So very easy to mix and match.
And if you can avoid having to do, more electronics, right? 1-to-1 for modules, that's always nice. All right, so those are the cases, right? So we can have a 3741 compliant system with, installing an SMA Core 1 or Tri-Power X within that 1 foot boundary. So that's, the design side of it. And then when it comes to actual installation techniques, we have, these are snips from our installation addendum, 3741 installation addendum for the south face system. And this is just to give you some examples, when, installers in the field or on the roof need to manage some of these PV wires, these module leads, right? So this is what a clean array would look like, with all of the wiring either protected underneath the array through wire management clips, creating an air gap here so that the conductors are not touching any live metal parts, or if they do have to jump between rows, in a row spacing, or from east-west, we have the ability, the approved means, to use a cable tray with a cover on it, and or a flexible liquid type flexible conduit to get your module leads from row to row. And the standard and the actually tests these types of wire management techniques as well. So through that testing of dropping the axe and the heavy bag, these things are tested in that same manner. And I have up here a snip from the actual standard. So there's multiple ways that you can address the wiring, the conductors touching live metal parts. One of those is to not have metal parts, but that's a little bit tough when you're dealing with aluminum frame modules or steel frame modules for that matter. But yeah, so there's multiple ways to do it, but the easiest, or the way that we're talking about here, is to have that controlled air gap. So you can see here like a positioning device, or an S-clip, the trade name for it, but it cannot be metal is the other thing. So non-conductive, right? So it has to be a plastic part here. So that's why we have the, and you can find this on our addendum, but it's the Hellerman Titan, I forget the exact model, but Hellerman Titan cable tie and edge clip that is approved for use with the south face. All right. Wanted to get into a little bit of the features of the south face system itself, and then I'll let Mike talk about the SMA inverters as well. But south face system is a 10-degree ballasted system with adjustable inter-row spacing. So that's kind of the main feature that we're excited about. So we can go from 8 inches up to 18 inches of adjustable inter-row spacing. We have pre-assembled clamps, so we're using the same cross clamps, which is our universal mid and end clamp for our typical residential systems, flush mount systems, all of our railless systems as well, and our ballasted systems. So one clamp across all K2 solutions, and those are they simply 90-degree turn into the chassis, so there's no assembly required. We have pre-installed roof mats with patented load absorbing features, right? So thermal movement, snow load, uplift from the roof, uplift from the wind on the roof. We have alignment tabs on the north side legs of the chassis that help you to not only stage modules while you're wire managing, but also to keep the array square. And then we have all additional accessories for wire management, hybrid attachment styles, and leveling across roof undulations. So here's an example of that 8 to 18-inch inter-row gap that I was talking about. So we have on the left that 18-inch gap, on the right an 8-inch gap. Still able to walk through there and manage some of the wires, but we're just giving the customers design flexibility. That was the whole idea when designing this system, was allow the customer to decide how they want to install it, instead of giving them a fixed inter-row. So it's You can use this for regional latitude-based optimization. Down in the southern states, might be able to get away with an 8-inch without too much shading loss. Up in the north here, I'm up in Albany, New York. It might help to go all the way up to maybe a 15 or an 18-inch in-a-row spacing. So yeah, again, just giving the customer that adjustability, let them decide. Do they want to go for the increased power density? Are they not too concerned about shading loss? Or maybe are they installing a 3741 system and they want to have those increased gaps to avoid any shading loss? Here's a quick little power density comparison. Just 20 modules, 30 modules, but you could scale this up and do some comparisons for yourself. But on the left here, we have the Ridge chassis by itself with the end clamp and at an 18-inch spacing. And if we assume, let's say this yellow line here is our fire setback on the roof, now we're actually unable to get that fifth row of modules into the array because the racking now is protruding into that fire setback. So instead of 25 modules, we're going down to 20, whereas on the right here, we do offer a north side and south side edge chassis as well. So the Ridge is going to be the main chassis throughout the array. The Valley is for the south, Summit is for the north. And those tuck underneath the array to create like a little bit of a 4 to 5 inches of protrusion from the modules themselves versus like a 20 or 30-inch chassis sticking out. And now on here on the right here, we were able to get to an extra 10 modules just by going with the custom chassis on the south and north edge and an 8-inch spacing versus an 18-inch. One of the other nice features is it's 2 SKUs. So it's, like I said, those mats come pre-assembled, the clamps come pre-assembled, pre-installed, the mats on the chassis, and then pre-assembled clamps. So it can be a two-part system with just the Ridge chassis. Now, if you want to add those custom chassis in as well, or go for some hybrid attachment, there, it'll bump the part numbers up, but essentially it could be a 2-part system. And here is those alignment tabs in action, using those to set the module down before even clamping and doing some wire management and also squaring the array. Now here's the cross clamp I was talking about. It's our universal mid and end, which is also universal in multiple senses. It's a mid and end clamp. It goes from 30 to 45 module frame, height module frame. So kind of agnostic to modules, universal to modules, but also universal across all of our systems. You can use it as an end clamp with or without the sleeve. It's not structural. It's just an aesthetic sleeve to hide the hardware. And it's designed for serviceability, so creates a nice, easy 1 or half-inch gap, and that it's a 2-piece design. So that top clamp will actually, if you need to go out and perform some O&M operations, some serviceability operations, you can release that top of the clamp where the bottom will stay right in the rail channel of either the south face chassis or our cross rail flush rail system. And there we go. There's an image of it. One of the other nice features, or one of the design considerations when creating this cross clamp, was we wanted to future-proof it, right? So it's that top clamp is 50 millimeters of clamping distance. And the same thing with the south face chassis. We wanted to, future-proof that. So we made it a little bit wider. I think it's about 29, 30 inches wide of a chassis. You're looking at it, you're like, why is it so wide? Well, we designed it because, as modules are getting larger, we're seeing, looking into the module manufacturer's installation manuals, we needed to comply with those clamping zones, or we wanted to comply with those clamping zones to get the most amount of pressures, design loads from the modules. So that's what we're seeing with some of these. Here's just 2 examples of I think REC and Silfab commercial modules requiring around that 13 inches or 12 inches of clamping, versus maybe some narrower chassis that you might not be getting those module clamping zones. Again, if we look at module compatibility, 50 millimeters of clamping on our cross clamp, but a lot of manufacturers are now requiring at least 40 millimeters, some even more than that. And we can always, we've seen some that go up to 60 or even 80 sometimes. So we've future-proofed it to be able to design it a different type of top clamp to allow for, as modules get bigger, if they're requiring more grip length. Here's that dragon clip going back to UL 1565. So this is not on our first go around of the 3741 approved components list, but we're in the process of updating our 3741 listing because we're getting the dragon clip 1565 certified. So it is an easy to handle ergonomic design wire management clip that it can hold up to 4 PV wires. So you can see in the images here, you can keep that consistent air gap because it has 2 sides to it, kind of like a basket style, and then another side tucked in right underneath the module frames. And then here's just some of the accessories. Like I said, that anchor bracket for hybrid attachment, and then extra south face mats for leveling. We have conduit clamps as well for east-west conduit runs across the backside of the chassis. So on the summit and ridge, there are accessory holes here that will help you run your conduit and manage your wires. Maybe your home run wires that you don't want to run through the module frames with some clips. You could use our conduit clamp and go right on the outside of those modules.
That's so cool. The image of the chassis and the modules being laid down, and then that dragon clip using, without module level devices, it's so much easier for wire management and kind of critical for successful 3741 listing, all that wire management to reduce possible shock hazard. And then
exactly.
The
we were
clamp,
thinking ahead. Yeah,
nice.
We wanted to be able to get 4 wires in there. We understand it's not just module leads. You got to deal with the home runs as well.
Yeah. And then, hopefully the SMA inverters can provide almost as much flexibility. The Tri-Power X inverter is the smaller commercial inverter from SMA, and both the Tri-Power X and the Core 1 are 277 480 machines. The voltage input range is very wide on both product lines and is the same voltage range. So again, stringing that works for one should work for the other. So mixing and matching these products on a single job should be very straightforward. The one primary difference to be aware of, I think, between the Tri-Power X and the Core 1, we kind of mentioned they're different power classes. The Tri-Power X is a newer line and so has a higher current rating per input on the DC side. So for larger format modules or bifacial modules, especially you're on the nice white TPO roof, you got some good spacing between the rows, you might get some good backside gain. The Tri-Power X might actually be a better fit for some arrays because it has a higher current limit than the Core 1. That's really the primary difference between the 2 product lines. Otherwise, they're very, very similar. So the Tri-Power X is there for 20, 25, or 30 kW. And the inverter itself is meant to be bracket mounted or wall hung, but we have, we show on the next few slides, some accessories that can make this very easy to place around the array for those roof mounted arrays. So there is a roof mount kit for this inverter that will hold it at a 15-degree tilt angle. You see that inverter placed here, and there's also 2 other accessories shown in this image attached to the inverter. The AC disconnect is an accessory there, may be very useful for lots of installs. And the box on the lower left of the inverter body is just a physical cover around where the DC conductors come into the inverter. So those conductors are mated to the outside of the inverter body. So they're Amphenol H4 plus connectors, and those are bulkhead mounted. So quite often customers want some type of physical cover for that area, something they can bring conduit right to. So that's what that accessory is. That gray box coming off of the inverter body is just a physical barrier that a conduit can be mated to, and bring the DC conductors there to the inverter body.
That's cool. That is very clever. Yeah, I like that. I mean, coming from an install background, I was a foreman for a commercial crew for 3 years, and yeah, I've installed a lot of these types of systems where the MC4s and the wires are just going, kind of, they have, a couple feet section where it's, just exposed. And so that is really cool.
Yeah, exactly. And kind of along the lines of 3741, having that, additional barriers and separation and physical protection is very, very useful. But the roof mount kit then, should allow for placement of this inverter very close to the array to ensure that those DC conductors don't protrude more than 1 foot from the array boundary. Then as needed on the AC side, the inverter will control those conductors. And this is just a little more detail on what that physical touch protection accessory looks like for the DC side. Very similarly, the Core 1, this is a slightly larger inverter. This product's been around for probably about 7 years now. Very, very popular commercial inverter. Little bit larger power classes than the Tri-Power X. So there's a 33, a 50, and a 62.5 kilowatt model. But the Core 1 was designed to be a freestanding inverter. We include 4 commercial rooftop feet for this inverter. So placement of this wherever advantageous, and again, through the lens of 3741, so that those DC conductors would not protrude more than a foot from the array boundary. This inverter is intended to be able to be placed wherever would be convenient for site location or code compliance, or both. But very straightforward installation and similar layout to the Tri-Power X, where the DC conductors are then, you can kind of see on the lower right of the inverter body in this image, is where those conductors come to the inverter. So as long as that connection can be made within a foot of the array, or again, physical attachment to the array per code makes the inverter part of the array. But allows for a lot of flexibility. And the Tri-Power X, there are 3 independent input tracking channels. The Core 1 has 6. So lots of flexibility for different string lengths for both products coming into the inverter. A lot of flexibility to fill all the addressable space on that roof with PV, but allow for lots of different string lengths to come to each inverter. So aiming to provide customers as much flexibility as possible for filling that roof with PV.
Awesome. All right.
And then some of the benefits we've focused, I think, primarily the, again, objective of 690.12 is for firefighter safety. But then there are a lot of add-on benefits to utilizing 3741 for system design. Obviously, if there is a removal of hundreds, perhaps even more RSD devices, that is a lot of upfront equipment cost savings, obviously some installation time savings, but there are a lot of overall system reliability and functionality benefits as well. Every single one of those RSD devices that you add adds to the system on the DC side, lots and lots of number 10 or number 12 conductor length, which are just energy vampires. You can have voltage drop across all of that additional conductor length for no additional power benefit. So you're losing power on the DC side, robbing the system of performance. But more importantly, for the reliability of the system, is you're adding a very large number of DC-DC connectors within the array. And as we can see in this top right chart, in one of the Mayfield Renewables webinars on 3741, looking at that lowest bar, dissimilar connector types were seen as one of the, clear and away major causes of failures in PV systems. So it's well known that mismatched or maybe poorly constructed field connectors are very well-known sources of failures and possible, euphemistically called, thermal events within PV arrays. So removing those to the extent possible and relying on, the PV module connectors are, highly automated and tightly quality controlled manufacturing facilities. And so as long as those are joined together correctly in the construction process, should be very reliable. So removing all additional needed DC connectors within the array is a great benefit to overall system reliability and honestly safety. So those are all great add-on benefits over and above firefighter safety to utilizing UL 3741 and removing rapid shutdown devices within the PV array.
Yeah. And I'll just add, lower lifetime. I mean, you're kind of already touching on it, but lower lifetime service and O&M costs, right? I can't tell you how many times we would get service calls when I was at installation firms where you're out replacing those module level electronics.
Yeah, and like you say, I mean, the South Face system is very nice. You have a very easy setup to go in there and lift modules and access it, but you don't want to have to do that. You don't want to have to go out there and troubleshoot and do that. So yeah, to the extent possible, removing those devices that are in a pretty extreme environment as possible service points, taking them out of the system is just a great way to extend the lifetime of these systems.
Well, great. I don't know, I think that was it. Yeah, here we go. So I'll just end by, like I kind of mentioned in the beginning here, we have, project services team, our regional product specialist team that will help you if you have any questions about designing for 3741 systems, and even some of the installation techniques, some of those cases and wire management techniques we're available to help. And then we have our design tools as well, K2 Quote, which is more of it says it right in the name, a quote tool to get you a quick bill of materials and pricing. But it started out as just a quote tool, but we're building in some engineering background to it, so you can get some spans, attachment spans, and design loads at those spans, uplift, shear. But we also have our K2 base design tool, which is going to be more for what we're talking about here, the South Face system. That requires more ballast calculations, wind calculations, seismic, all of that good stuff. So we have all these tools available for you. Reach out if you need any help with them. You can also just go on and create a login yourself and start messing around with those tools yourself. But yeah, that was really it. I mean, it's not really I don't know if we can still keep calling it a new standard. It's new in implementation, I believe, still,
Exactly.
It's been around for a while now, since the concept, at least in 2017 code cycle. It was in the 2020 NEC now, but I think we're still kind of catching up on the actual implementation of it. There's been some systems installed out there to 3741, but hopefully, webinars and presentations like this with some of the benefits and maybe demystifying some of the installation techniques will help to get this moving in that direction.
Yeah, definitely. And I think SMA is endeavoring to at least have case studies where folks have successfully installed 3741 systems using SMA inverters to the extent possible around the country, where hopefully we'll make people realize that even if it's a fairly restrictive jurisdiction who likes to take a close look at everything, it's certainly possible to have them be comfortable with this, as you said, kind of new standard, new to them. So if there's anything SMA in terms of engineering can help with, we'd be happy to support as well.
Awesome. So Claire, did you have anything to add? Do we have any questions or anything that came up?
I don't see any questions in the chat.
All right.
If anybody is interested, they can leave them in the chat. We can add emails to the chat if anybody wants to reach out to either K2 or SMA. Otherwise, I believe that concludes this webinar. And thank you everybody for attending. Have a great rest of your day.
All right.
Indeed.
Okay.
Thanks again.
Thank
Thanks,
you.
everybody. Thanks, Drew.
Thanks, Mike.
Bye.